All right, our next section we're going to look at are absolute value equations, and what we're going to see is an absolute value equation works pretty much the same as a normal equation, except we just deal with these absolute value lines, and remember the absolute values could be either positive or negative. So if we look at this example on this title page, you can see we got our absolute value of x minus 2, and if you think back when we solved quadratic equations, if I gave you something like x minus 2 squared minus 10, and we had a 3 out front equals 11, we basically did the same thing. We would get rid of the 10, we'd add the 10 to both sides. So that gave us 3x minus 2 squared equals 21. So you can see that step looks pretty much the same. Then we divided by 3. So that gave us 7. So once again, that's the same answer. So the only thing that's different now, when we had quadratics, we would square root both sides and solve. Now once we get it down to absolute values, we just got to remember it's got to be plus or minus. So all we have to do is solve x minus 2 equal to 7, or the negative of that, which would be minus x plus 2 equal to 7. So our answers end up being 5 or, negative 5 or 9. So in this case, if we plug a 9 into the original, it works. If we plug a negative 5 into the original, it also works. So what we're going to see with absolute values is we actually get usually two different answers, so the positive and the negative version. And that's really it. So all you got to be careful of is follow all exact same rules you do for quadratics, except we want to isolate that absolute values, treat it like just one big variable, just like we did with quadratics. And then what we want to do is we want to get rid of the absolute values into just regular brackets and solve the positive and the negative. So if I go back to the title page here, if we think of this as being the positive version, just x minus 2 equals 7, that gave us 9, sorry. And if we did the negative of the original, so minus of x minus 2, that's why I wrote minus x plus 2. So the negative of it just does the opposite signs, and that would give us the negative 5. So that's it. We just basically have to solve two equations, solve them both, get our two answers. The only thing you want to do is you actually plug those answers back into the original to see if they work. They not always will they work out the same. Okay, so this next one here, we got x plus 3 equals 7, so we want to solve it as a positive and as a negative. So we just put that on both and solve away. You could actually, if you really want to, we could do it as x plus 3 as positive and then put the plus or negative on the 7, and you get the same answer either way. But it's usually better to write it like this because it'll help us later on when we're graphing. So if it's positive out front, we'd have x plus 3 equals 7. Okay, so add minus 3 on both sides, we get x equals 4 as our one answer. Let's do the same thing with the other one. So the minus on the brackets will make it minus x minus 3. Add 3 to both sides. Divide by the negative 1. So we get negative 10. So we have two different answers. Let's plug them both back into the original. So if you put a 4 in, is absolute values of 4 plus 3 equal to 7? Yes, because that would be 7 equals 7, so that one's good. Try it again for negative 10. So you'd have negative 10 plus 3. That would give us negative 7. Is that equal to 7? Yes. So they're both good. So in this case, both answers are valid, so we have two different solutions. Okay. The next one, what we want to do is the exact same thing, but you can see we just have a little bit more complicated equation, but solve it the same way. Do the positive of the absolute value equals 5 minus 3x, and do the negative of the absolute value. And then just solve each of those. So we'd have 2x minus 5 equals 5 minus 3x. Let's bring the 3x over, so that make it 5x. Add 5 to both sides, it would give us 10. Divide those out, we get 2. Do the same thing on the other one, so we'd have minus 2x plus 5. Let's move the 3x over, so we add 3x, that would give us 1x. Let's bring the 5 over to the other side. We get 0, and that's our other answer. So plug these back into the original and see if they work. So if we plug the 2 in, we'd have 2 times 2 minus 5. And is that equal to 5 minus 3 times 2? So we'd have 4 minus 5, which is 1. So absolute value of negative 1. Is that equal to 5 minus 6? 5 minus 6 is negative 1. Absolute value of 1 is 1. So that doesn't work. So that x equals 2 is not a good solution. So we call that one extraneous. Do the same thing for the other one. Plug in a 0, so we'd have just absolute value of negative 5. 5 minus 3 times 0 would just be 5. Is that the same thing? Yes. So in this case, only x equals 0 is a valid solution. Okay, so this one, we've got another equation, so let's solve it the same way. You want to do the positive version of 3x minus 4. Everything else stays the same, and the negative version of 3x minus 4. And that's it. So let's simplify that. So we have 3x minus 4 plus 12 equals 9. This one we got 3x minus 4 minus 3x plus 4 plus 12 equals 9. I'm just showing you a different way. We could have brought the 12 over right away to make it negative 3, which is totally fine, but let's try it this way. So if we solve this one, we get minus 4 and 12 would be 8. Bring that to the other side, that would give us 1. So we would get x equals a third. If we get the other equation, we'd have 16. Bring that to the other side, we get 7, negative 7. Divide those out, we get 7 thirds. So we have our two different answers, but what happens now when we plug them in? We go 3 times a third, that's 1. So we'd have 1 minus 4 absolute values, which would be negative 3, which would be positive 3. Is positive 3 plus 12 equal to 9? No. So that one doesn't work. Try the 7 thirds. 7 thirds times 3 is 7. 7 minus 4 in absolute values would be 3. Is 3 plus 12 equal to 9? No. It doesn't work either. So in this case, neither of them work, so our answer would actually just be no solution. So I'm showing you as we solve these, there's a couple different ways of doing it. Just change them to plus and minus and solve. Or like I said earlier, if we wanted to, we could have just rearranged this equation first, bring the 12 over. So you'd have 3x plus 4 equal to negative 3. So now you can see why there is no solution. This absolute value of whatever's inside there is always going to be positive, so it's impossible to get negative 3 for an answer. So that might have been a better way to write it, and then we would have figured out that there's no solution a little bit sooner. Either case, it always works no matter how you solve these. Okay, that one's the same. We'll skip that one. And let's try now a couple quadratics, because they work the same as normal quadratics. So same thing here, we should have x squared minus 2x as a positive equation equal to 1, and minus x squared minus 2x equal to 1. So when we simplify that, we'd have x squared minus 2x. Let's bring the 1 over, because remember with quadratics we want it to be equal to 0. And do the same thing on the other side, so we'd have minus x squared plus 2x equal to 1. But let's bring everything over the other way. Let's make it 0 equals positive x squared minus 2x plus 1. And all that does is it just helps us keep our x squared positive. And that's it. So now we're ready to solve. So how do we solve quadratics? Graph, factor, quadratic formula, whichever method you want. So this one I think factors. So x minus 1 and x minus 1, that's good factors. So in this case we should get x equals 1 for one solution. And if we plug that into the original, we'd have 1 squared minus 2, which would be negative 1. Absolute value of negative 1 equals 1. So that one does work. The second one here, not quite so easy because it doesn't factor. So we could either graph it and get decimals, or we could do quadratic formula. So let's do the quadratic formula to remember how that works. So our quadratic formula is b squared minus 4ac in that square root part. So we just plug in all our numbers. So we'd have 2 plus or minus 4 minus 4ac. So it'll be 4 times 1 times negative 1. So that'll be plus 16 over 2. So if we simplify that, we get 2 plus or minus root 20. And root 20 we could even break down into root 4 and root 5. So that'd be the same thing as 2 root 5. So this one actually simplifies to 2 plus or minus 2 root 5 over 2. And we can actually cancel out all the 2's. So our final answer is 1 plus or minus root 5. So that would be our exact solutions for those two. Once again, we should plug them both in to see if they actually work. So if you put in 1 plus root 5 on your calculator, get that as a decimal, square it. So 1 plus root 5, I'm just typing it in here to see if it works. So 1 plus root 5, it equals, that gives us 3.236. So let's square that and we want to minus 2 times that answer. And that gives us 4. Is the absolute value of 4 equal to that? And the answer is no. Okay, something's wrong here. Let me figure out where we made our mistake. Okay, I figured it out. When I did our 4AC, we went 4 times 1 times 1. I wrote 16. That should have been just 4. So we should have had 4 plus 4, which is root 8. And root 8 would simplify it out to be 4 root 2. So this should be a root 2 instead of root 5. So we should have 1 plus or minus root 2. So let's try that now and see if it works. So if we go 1 plus square root of 2, that gives us, so 1 plus root 2 gives us 2.41. So let's square that. Minus 2 times that same answer equals 1. So absolute value of 1 is 1. So the positive for sure works. Let's try the negative. So 1 minus root 2, and square that, and minus 2 times that same answer gives us positive 1 again. So they do both work. So 1 plus or minus root 2 and positive 1 are all 3 are valid answers. So let's try one more. Here's another quadratic. So we'd have x squared minus 10x. Our positive version would be just x minus 10. It would stay the same. So let's simplify that. Let's bring the 1x over, so that'd make it 11. Let's bring the 10 over. So there's our first equation. And then we'd have the exact same equation again, except it would be the negative of x minus 10. So that would make it minus x plus 10. So when we bring that to the other side, we would have minus 9x, the minus 10 plus 1. And bring the 10 over, and that's it. So there's our 2 equations. Try factoring once again. The first one works good. We'd have minus 10 and minus 1. So our answers are 10 and 1. And for our last one, we would get minus 10 and plus 1. So our answers here would be 10 and negative 1. So you can see we have 3 different choices, 10, 1, or negative 1. So once again, let's plug it into our original. So if we put 10 into the original, we get 10 squared minus 10 times 10, which is 0. 10 minus 10 is 0, so definitely 10 works. Plug in the 1, we'd have 1 minus 10, which would be negative 9. 1 minus 10 on the other side would be negative 9 again, but as absolute values, so that isn't the same. So that's no good. Let's try negative 1. So we'd have negative 1 is 1, plus 10 would be 11. And on the other side, we'd have negative 1 minus 10 would be negative 11. Absolute value of that is positive 11, so that one's good. So then the 10 we've already done on the other side, so we're good. So in this case, just 10 and negative 1 would be our final solutions. So they're pretty easy. Most people don't have too much trouble with these unless you have to do quadratic formula or graphing or whatever to get decimal answers. Just basically remember to solve the positive version, the negative version, and always test your answers to see if they indeed work out or not. And that's all.